Hello friends, once again we meet and this time we are going to look at exercises in matter waves. Yeah, the first one is almost solved and everything is right. Direct formula we are applying, that is we are given a particle which is accelerated or an electron which is accelerated through 100 volts. So you simply put the value of volt and you get the answer. Yeah, go to the next one, something very similar. Calculate the momentum of a photon which with a radiation frequency of this much, given h is equal to this, hc is given, momentum is h by lambda, and lambda can be written as v by c, so we get the value of momentum. So most of the sums are related to writing the formulas here and there, juggling around with the formulas, that's it. Now here we are given the kinetic energy of an electron orbiting the first excited state of hydrogen atom. So it has an energy of 3.5 electron volts. So we use lambda is equal to h upon root of 2 mk, and k value is given to you in electron volt. So you'll have to convert that into joules because lambda will come in meters. Here kinetic energy of an electron accelerated through a potential V equals the energy of a photon of wavelength this much. So a photon of wavelength this much will have its energy equal to hc by lambda, that is h upon c into 45460 10 raised to minus 9. So once you know the energy, you put it into the value of getting the wavelength. V will be equal to h upon root of 2 mk. Instead of k, you put hc by lambda. Most sums involve only calculation. Next is calculating the de Broglie wavelength of an alpha particle accelerated through potential difference of 200 volt. The mass of the proton is given as 1.6 into 10 raised to minus 27 kg. So it will be h upon root of 2 MeV. 2 into mass of the proton, E is the charge of a proton, 1.6 into 10 raised to minus 19. Voltage will be 200. Let's go ahead. So a particle is moving 3 times as fast as an electron. So the velocity of the particle under question is 3 times that of the electron. The ratio of the de Broglie wavelength of the particle to the electron is this much, that is lambda of the particle upon lambda of electron is 1.89. That should be equal to momentum of electron upon momentum of particle. Since we know the ratio of velocity and the mass of the electron, we can calculate the mass of the particle in question. So hp will be h mp upon v. So he will be equal to h upon mv. So as I told you, mass of the particle upon mass of electron will be mass of electron into velocity of electron, mass of proton into particle into velocity of the particle. Now we are given that the velocity of the particle is almost 1.81 into 10 raised to minus 4 times, and mass of that part, so velocity is 3 times the velocity of E. So putting all this thing over here, we'll get the mass of the particle and it should be a proton. That you could figure out when he has given the value 1.81. Find the de Broglie wavelength associated with an electron moving with a velocity half, 0.5 is half the velocity of light, and its rest mass is given. So you can find out the momentum, mass into velocity, and h upon that will give you the value. Now you can't directly do it because it's in speed relative to that of light, so you'll have to use this formula. So first you'll have to calculate m will be equal to 1 upon velocity, that is 0.5 times c upon this, so it comes out to be this part. Now your lambda will be h upon mv. So we will write this as this upon m0v. M0 will be equal to this much. Find the typical de Broglie wavelength. Now here temperature, we have to figure out what should be the velocity of the electron at that temperature. 27 degrees Celsius, if you convert it to Kelvin, will become 300. So 2 mk T. K is Boltzmann constant and T will be temperature in absolute terms. Now mass of the electron is known, temperature is known, so you put 2 bkBT and it turns out to be 6.2 into 10 raised to minus 19. Separation between two electrons in a atom is approximately this much, so the ratio will work out to 31 times. He is asking you the ratio between the wavelength that we are talking about and the separation between two electrons in a metal. So lambda is 31 times that, so lambda is much greater. Equivalent wavelength of a moving electron has the same value as that of a photon having energy this much. And you have to calculate the momentum of the electron. First you have to find out the wavelength. You are given the energy of the thing. So energy of the photon is E into hv will be hc by lambda. So your lambda will turn out to be hc by E. Energy is given to you. So P will be equal to h by lambda. So I put the value of lambda over here and you get it as 2 into 10 raised to minus 25 kg per second. This is a rather verbose sum. There's a lot of words in it. What it tells you is the extension of localization of an element is determined roughly by its de Broglie wavelength. So what we want to say is where the electron lies, in which region of space, is roughly given by de Broglie wavelength. If an electron is localized within that radius, that is 10 raised to minus 14 is the radius of the atom, we will have to calculate its energy. To calculate its energy, we use the lambda as equal to 10 raised to minus 14. Okay. Then we compare the energy or the binding energy of a nucleus. That will be secondary. So lambda is given to us. When we do, we will get it as 8.63 into 10 raised to minus will be the momentum. We can't directly key in the momentum. We will have to write everything in relativistic term. So here energy will be equal to P square C square plus m0 times, m0 is the rest mass of an electron. Pc is the momentum which we calculated into the speed of light. And we try to convert it into electron volt, so you get this much electron volt. Now that you see is too much large compared to the binding energy due to the Coulomb's force. So therefore electron cannot exist within the nucleus. So we have to find out the de Broglie wavelength associated with a helium atom at room temperature, that is 300 degree Kelvin and 1 atmosphere pressure. Compare it to the mean separation between two atoms under these conditions. First of all, we have to find out, if you know the temperature, you can find out the wavelength by using h upon root of 2 mk. Okay, so first we have to find out mass, atomic mass upon Avogadro number will give you the mass. Temperature is given to you and half will be equal to this. So your m square v square will turn out to be 3 mkt. That will be the momentum, and put it over here, you will get the value of lambda as this much. Just for the sake, you have to find the mass of an atom. Mass of the helium atom is not given to us. For that we have taken atomic weight of helium, it is 4 divided by Avogadro number, which is 6 into 10 raised to 23. In grams it works out to be this much. We multiply by 10 raised to 3 to convert it into kilogram. So we get 2 by 3 10 raised to minus 6 kg. Temperature, as I told you, is in Kelvin, so 27 plus 273. Average kinetic energy will be equal to 3 by 2 kT. Half mv square will be equal to this. So multiply both sides by m and you will get m square, v square is this. So momentum will be given by this quantity. Put it in this value. Now you know the value of k. K is Boltzmann's constant. Mass we have calculated over here. 2 by 3 into 10 raised to minus 26. Temperature is 300. So substituting all these things, you get this value. Going back, we try to find out the kinetic energy per mole will be PV upon RT. So V will be upon N. V is the volume, N is the number of turns. It will turn out to be this part. So the separation is molar volume upon Avogadro's number. Molar volume upon Avogadro number will be kT upon P. T is 300, P is 1 atmosphere, K Boltzmann constant is a thing. So you get radius as 3.4 into 10 raised to minus 9 meter, whereas the lambda which we calculated is 0.7 into 10 raised to minus 10. That's it, friends. So we have come to the end of this exercise. More exercise from competitive exams like the NEET, JEE and other exams will be taken up in the course of next few classes. Till then, we meet again. Goodbye and do take good care of yourselves. And don't forget to subscribe my channel, okay, and do comment so I can change my lecture so as to be more effective in delivering it. Thank you.